Hello everyone, today we're going to explore the fascinating world of diodes. Now, you might be wondering what exactly is a diode? Well, a diode is a two-terminal electronic component that primarily functions as a one-way street for electric current. It's much like a check valve in plumbing, which allows water to flow in one direction but blocks it in the opposite direction. In the realm of electronics, diodes are represented by a specific symbol in schematic diagrams. This symbol consists of a triangle pointing towards a line. The triangle represents the direction of current flow from the anode, the side without the line, to the cathode, the side with the line. Diodes may seem small and simple, but they are actually quite crucial in the functioning of many electronic devices. Now that we know what a diode is, let's see how it works. Diodes work due to their unique semiconductor properties. To understand how a diode functions, we need to delve a bit into its atomic structure. Inside a diode, we find two distinct types of semiconductor material. One is N-type, which carries a negative charge, and the other is P-type, carrying a positive charge. In the N-type material, free electrons are the majority carriers, while in the P-type material there are holes, or absence of electrons, which are the majority carriers. These two materials are joined together, creating a junction in the middle. When a voltage is applied across a diode, something fascinating happens. The free electrons in the N-type material start to move towards the P-type material. Simultaneously, the holes in the P-type material move towards the N-type material. This movement creates a region along the junction where there are no free carriers, known as the depletion zone. In a scenario where voltage is applied in the reverse direction, the depletion zone acts as a barrier preventing current flow. This is what we refer to as reverse bias. However, if the voltage is applied in the direction from the N-type to the P-type material, the depletion zone shrinks and current starts flowing. This is known as forward bias. To put it in simpler terms, in the forward bias condition, the diode acts like a closed switch, allowing current to flow. But in the reverse bias condition, it behaves like an open switch, blocking the current. This unique property of allowing current to flow in one direction and blocking it in the other has a wide range of applications, from rectifying AC to DC, to protecting circuits against reverse polarity, to controlling electronic signals and much more. Now that we've got the theory down, it's time to see this in action. Let's demonstrate this with a simple circuit. Opening, here I have a diode connected in series with an LED. As we delve a little deeper into our exploration of diodes, let's see one in action. This small, seemingly insignificant component serves a great purpose in the field of electronics. To demonstrate its function, I've set up a simple circuit on our workbench. In this setup, we have an LED, which stands for light-emitting diode, and our main component of interest, the diode, connected in series. For this experiment, I've connected the cathode of the diode towards the positive side of our power supply. Remember, the cathode is the side of the diode with the line, according to the symbol we discussed earlier. Now, let's see what happens when we apply a voltage across this circuit. As we power up the circuit, observe the LED. Notice how it lights up? This is because the diode is allowing the current to flow in the forward direction. The diode, acting as a one-way street for electrons, lets them flow from the anode to the cathode, thus lighting up the LED. But what if we reverse the voltage? When we swap the positive and negative ends of our power supply, the LED does not light up. That's the diode at work again. But this time, it's blocking the current. The diode is now in reverse bias, and the depletion zone within it acts as a barrier, preventing current from flowing in the opposite direction. Through this simple experiment, we've witnessed the crucial role a diode plays in controlling the direction of current in a circuit. It's like a gatekeeper, ensuring that electrons only travel in the right direction. In conclusion, diodes may be small, but their impact on the world of electronics is immense. They regulate current direction, protect components from damage, and enable the functioning of many electronic devices we use daily. Ending. So diodes are essential in various aspects of electronics. You might be wondering, where do we use these diodes? Well, these tiny components are the real workhorses of electronics, making everything from your smartphone to your microwave function as they should. So let's delve into a few key applications of diodes. Firstly, diodes are widely used in rectification, a process that converts alternating current, AC, into direct current, DC. You see, our power lines carry AC, but most electronic devices need DC to operate. That's where a rectifier consisting of several diodes comes into play. It only allows the positive half of the alternating current to pass through, turning it into a unidirectional current, which is our DC. Secondly, diodes play a critical role in voltage regulation. Zener diodes, for instance, are designed to maintain a steady voltage across their terminals, no matter how much the input voltage or load resistance may change. This is why they're often found in power supplies and voltage regulators, ensuring that our gadgets receive a stable voltage supply. And let's not forget about signal modulation, another significant application of diodes. In radio and television broadcasting, for example, diodes are used to extract audio or video signals from their carrier waves in a process called demodulation. Simply put, they help us listen to our favorite radio stations and watch our beloved TV shows. Moreover, diodes are also used in electronic switches, logic gates, temperature measurements, and many other applications. Light-emitting diodes, or LEDs, are a type of diode that emits light when current flows through it. They're used everywhere, from our home lighting and car headlights to our computer screens and smartphone displays. So, whether you're charging your phone, adjusting your room's temperature, or simply watching this video, remember that none of these would be possible without diodes. These are just a few examples of how diodes make our electronic devices work. They may be small, but their impact is substantial, silently powering our digital world. So, let's quickly recap what we've learned today. Diodes, those little components on our workbench, are more than meets the eye. They're two-terminal devices acting like electronic check valves that allow current to flow in one direction while blocking it in the other. This fascinating behavior is due to their unique semiconductor properties with N-type and P-type regions and a middle depletion zone that acts as a barrier to current flow in reverse bias. In forward bias, however, diodes let current flow freely. It's this principle that we've seen in action today, with our simple circuit lighting up an LED thanks to a forward bias diode. From protecting circuits to converting alternating current into direct current, diodes have a wide array of applications in the world of electronics. Thank you for joining us today. Keep exploring and stay curious about the world of electronics.